Let's now try to design a more FSM to detect the sequence 010. Overlapping sequences have to be detected as well. So before we design the FSM, let's try to fill out this table here. We have a clock which goes for 15 pulses, and we have the input X, and we have to determine Z. Z is equals to 1 when the sequence is detected. Now the first instance that you see the sequence 010 is this one here. The second instance is this one. Remember, overlapping sequences are now allowed. This is the third instance. This is the fourth instance. The first instance is detected in cycle 4, therefore your output is asserted in cycle 5. Remember, this is a more FSM, so your output is going to lag by 1 clock cycle. The second instance when the sequence was detected is at cycle 6, so in cycle 7, output is asserted. Third instance is at cycle 10, so at cycle 11 it is asserted. Fourth instance is in cycle 13, so it is asserted in cycle 14. Now let's try to come up with the FSM or the state diagram. Remember, we are trying to detect 010. So the initial state is the reset state. So that's S0 with output 0. You reach that when you hit the reset button. So S0 corresponds to the reset state. From S0, if I get a 0, I move to state S1. My output is still a 0. So we always go in the path to detect the sequence. So S1 is a state which can be reached from the reset state if you give the input 0. Next, we move to S2 when you get a 1. And your output still remains a 0. So S2 is a state that you can reach from the reset state if your input bits are 0 and 1 respectively. Next, we move to the S3 state when we get the input 0. Now the sequence is detected, so our output is 1. So S3 is a state which can be reached from the reset state if your bit pattern is 010, and the output is asserted. We are still left out with some more transitions. So from S0, we are completed with the 0 transition. We are left with the 1 transition. So if we get a 1 from S0, we remain in S0 because we haven't started detecting the pattern yet. So S0 can either be reset or 1. From S1, we are done with the 1 transition. So S1 was a state which you reach by having a 0 from the reset state. So from there, you can either get a 0 or you can get a 1. If you get a 1, you move to S2. If you get a 0, where would you go to? So if you look at this table here, there is no state with the pattern 0, 0. So eliminate the leftmost 0. There is a state with the pattern 0, which is S1 itself. So from S1, if you get a 0, you remain in S1. Next, let's go to S2. S2 was a state which you were able to reach from the reset state if your input bit pattern was 0 and 1. From there, you can either get a 0 or you can get a 1. From state S2, if you get a 0, you move to state S3. Now, if you get a 1, what happens? Is there a state with 0, 1, 1? No. Is there a state with 1, 1? No. Is there a state with 1? Yes, which is the reset state or state S0. So from S2, if you get a 1, you move to S0. Next, S3. S3 was a state which you were able to reach with the bit patterns 0, 1, 0. So from there, you can either get a 0 or you can get a 1. Now remember, if overlapping sequences were not allowed, we would have just eliminated these 3 bits here. But now overlapping sequences are allowed, so we cannot really eliminate those 3 terms or those 3 bits. So let's try to figure it out. So if you get a 0, that's 0, 1, 0, 0. Is there a state with 0, 1, 0, 0? No. Is there a state with 1, 0, 0? No. Is there a state with 0, 0? No. Is there a state with 0? Yes. And that's S1. So if you get a 0, you move to S1. And if you get a 1, let's see what happens. Is there a state with 0, 1, 0, 1? No. Is there a state with 101? No. Is there a state with 0, 1? Yes, which is S2. So from S3, if you get a 1, you move to S2. So now our FSM is complete with all the transitions labeled. This is how you can build a more FSM where overlapping sequences are allowed. And we are detecting the sequence 0, 1, 0.